My name is Torin. And I'm Pete. And we wanted to do a talk today on ShaderPark. So, how many people here have heard of shaders before? Yeah, I think like a little intimidating now. Like, how have you worked with shaders in the past though? I feel like shaders can be kind of this area of programming that are like super powerful, but are also really intimidating to get into. And Pete and I have been working long term on this project called ShaderPark that oh, went from night mode to day mode. Okay. That basically allows you to do 2D and 3D shaders, but try to simplify the process overall. And we started doing this early. I mean, we're doing like a meetup in college actually. So it's really fun to kind of see a progression of this as well. Like at university, there was kind of like two main tracks. You could do design or programming. And you were like, what if you could do both? And from there, no one was really doing creative coding. And so we started hosting these meetups where we'd basically teach like P5JS and shaders, 3JS. And out of that like initial meetup, it was actually an early prototype that started working on. I don't know if we actually have a video of like the early version of that. I could dig it up another time, but yeah, it's not immediately handy. But yeah, so kind of the original motivation for this project was particularly to have like an easier, quicker way to work with a particular kind of shader rendering setup called ray marching with sign distance functions, which is uh, some fancy word, but it's basically kind of an alternative way to work with like 3D graphics and 3D modeling. It's the type of thing that you see like on ShaderToy, if you've ever been on that website before, where there's a lot of 3D stuff that might have like fractals or morphing things. Who else been to ShaderToy? Raise your hands. Yeah, okay. If you haven't seen ShaderToy, we've got although mine's defaulting to ShaderPark. Um, this is also a great learning place if you're like getting into it, like go do a deep dive into this space. And also, Inigo's uh website, quiz. Yeah, there we go. This is like where a lot of people will go to like under the articles to be able to learn how these different functions work. But one of the things that we started noticing is that like if you look inside these shaders, you look at the implementation for something like this and you're like, oh my God, how did this person like figure out how to create this entire piece? Like they made this hash function. How did they do that? And then like even for shapes, like I feel like as a newcomer to this space, there's actually a lot of like repeated code that people are using that are kind of these like helper functions that Inigo has laid out here. And so what we wanted to do is try to like sort of make this standard library to make it a lot easier to get started with those pieces and start experimenting. Yeah, kind of the basic like initial concept was just like to have something sort of like ShaderToy, but with less or like more of the boilerplate sort of done for you, because even on ShaderToy, if you're experienced and you've done it before, it doesn't like allow you to import or save any like share things between projects. So you basically have like all of this boilerplate to like work with SDFs and ray marching every single time you're doing something. So this first sort of version of this was basically just like adding a library, adding it, making it more of like a framework so that you just implement like the piece of the shader that defines the geometry in the shading. And after we sort of had that first version of it, we iterated on it until eventually we made the leap from kind of what if instead of even just having the boilerplate done, you could create SDFs, you could create these kinds of geometries and animations just with like an imperative like processing or P5 kind of API where you just can with a single line like create a geometry like a sphere or a box. Almost like that. So exactly like that. The big leap there was seeing if we could take a higher level language like JavaScript and even we talked about this as well, that maybe even JavaScript isn't it's the most easily shareable language, but maybe something like Python in the future could be interesting to explore. But that once we used JavaScript to actually write the shader code for you under the hood, we're able to boil it down to these sort of single line definitions where we can start to like live code and do all of the setup for you behind the scenes for ray marching, but you get all the added benefits of easily scripting. And I think one of the big things here, and like maybe this is where could show kind of like blending between something. Um, there's a lot of really interesting techniques that you have available at your fingertips when you are actually doing ray marching. And I think one of the kind of like classic things is like these very like blobby looking shapes. Like normally, even making a sphere actually, like if you're using regular geometry, it's many points to make a sphere. But when you're working with a distance function, one of the simplest things to make is actually a sphere. And you get some really interesting pieces here where you can actually like blend between different shapes super easily.
There we go. Doing the one-handed typing here. Nice. There we go. So yeah, certain things that would be not so straightforward with normal like meshes geometries. SDFs have a lot of cool properties in how you can distort. You can do like constructive solid geometry operations like subtraction or intersection, and you just have a very sort of like free, flexible RAN to like manipulate the geometries that you're working with.
So one of the things I've been working on as well, and I also wanted to show the context of this because I feel like this is such a niche area of graphics programming, and it's so fun to experiment with. So we actually worked on bringing it into TouchDesigner. So we have a full plugin that you can use where any of the shader code that you write, I guess technically like JavaScript code, you can then bring into this environment. So I can just take this, for example, and we can bring it in. So I can do like a text and no. Yeah, the one-handed setup is something. So we can do text and then connect this in. There we go. We've got our kind of morphing geometry. And the thing that's really interesting here, if we actually go inside the component, this shader is actually a material. So the way this is working is that we're actually simulating, like if you look at the geometry, right? Like we have a sphere and this entire shader is wrapped on the outside of the sphere and we're simulating a full 3D scene inside the material. Like that to me kind of feels like magic. Uh, so like all of the like 3D things that you're seeing here, like in the browser, we're actually using like a giant cube that's being mapped onto it. So that if I just make this box really large, you'll see the same bounding box here. Same thing in the browser. We have a actual like the actual piece of geometry we're using is a 3D cube. Everything else is simulated inside the material.
Yeah, ray marching is actually like like a form of ray tracing. So the way that it creates the images, every single pixel, the fragment shader, which is normally just used to sort of like determine the material color, it actually like executes a whole like ray marching program to like intersect the geometry, to find the shape, which is a bit computationally intensive, but on the other hand, the representation of the geometry is usually a relatively simple sort of mathematical equation, which trades off and makes it not too expensive. And modern computers are really fast, so they can handle it.
Yeah, I was gonna show too that you can also like use it as a bounding box too. So if I instead like use a teapot, you can kind of see here like you could use text, but you can kind of see how like it's kind of a little bounding box for our 3D shader. And we've been doing some other really fun pieces too. So one thing that's really nice that you get from doing ray marching is that it's actually pretty straightforward to do reflections in theory. But basically you can kind of see from, I'll disconnect this maybe. Here's like a default one. We just wanted to make it super easy. So now you can like enable ray marched reflections. If I put it inside like a little 3D environment, it'd be a little easier to see, but you can kind of notice on the edges here, you get these nice little reflective pieces. But also we can mix between TouchDesigner's lighting and then our built-in material. So one of the things here, we can kind of use this use TD lighting. And if I crossfade this inside this component, you'll notice that I have a environment map here and I'm using a noise to generate this color. And we can even do things like turn on soft shadows. And actually, thanks to Joseph Pates, we were able to get soft occlusion with other objects in the scene, which is super fun. And also, have you all experimented with T3D at all? Yeah, let's go. So, yeah, worked with Yosef on this setup. So basically, what you can do, notice that this has a little output right here. If you want to use a distance field, or any object that you make in ShaderPark will output a snippet of code that you can then apply into T3D to use as the actual starting shape. Uh, and the other kind of secret sauce that I wanted to share today, this is a huge, huge shout out to Yosef and also Lyle. This is also officially now an operator family. So basically, the idea here, we're stringing together snippets of code. What if we could just create a series of operators here and use those to actually generate the shader code for you? So now we've got here, right? This is our box. We've got the size. We can really easily start to chain these things together. Here's our starting shape. Oh, I'm still using TouchDesigner's lighting. That's why. um, Maybe. Oh, actually, wait. I want to use a sphere because I want to show a short but sweet demo. I'm gonna do this, and before it, maybe what I'll do is mirror it many, many times. Yeah, I'm gonna make it really small. So I'm gonna make this like 0.01. And then mirror end's really interesting because what we can do is like take an object and we can like replicate it many, many, many times. So I'm gonna make this like point like 0.01, and don't mind me just swapping these around. But basically we can take this. We've got our teeny, teeny sphere that you can barely see in the background. And then I'm going to take this mirror n and I'm going to start to replicate it 1, 2 times. There we go. Let's do like 7 times. Oh yeah. uh, so kind of like what you'd imagine for instancing. But instead of actually like taking a piece of geometry and replicating it many times, we're actually taking the coordinate space, and we're like duplicating a coordinate space here. That's one of the other cool properties of SDFs as a representation for the geometry, is that you can do transformations like that, like mirroring and symmetry, to create, yeah, huge numbers of objects almost for free. You can use that to make like fractals or all kinds of interesting effects and geometries. And basically what I'm gonna do here is just kind of like combine these two together. I think is the last little example that I'll show. But we're kind of in like a default construction mode where we're just like adding new things into the scene. But you kind of saw before how we can kind of like blend between shapes. You can cut different shapes out. So we had this idea of like constructive solid geometry that you might be used to in like sort of CAD software. And you can do that very, very easily. And also I'm just gonna like kind of merge these together. Maybe I should have an operator for that, but uh, okay, so I'm basically gonna put this in maybe like an intersect mode. So in theory, if I connect these two together, or just connect the same operator to itself, uh, in theory, we can basically intersect this with another small sphere.
Put this first, or do a reset before, because otherwise the space is still gated.
Oh yeah, yeah. So yeah, one thing too is that like once you like apply a modification to the coordinate space, so we're replicating the coordinate space everywhere. Um, we'll just want to reset that. It'll basically pass down to other objects. So we'll reset it really quickly, and then now we can intersect it with the sphere right here. There we go. Look at that.
Wait, it's not. Yeah. Oh, but it's not back here. Yeah. What do you mean? It's not on the projector.
Oh, it's not on the projector. I'm seeing it. It looks pretty cool here.
Take our word.
Yeah, there we go. Hey. And then also you can change the construction mode. So here our construction mode is set to intersect. We can do a blend, so I can like smoothly blend between these two different shapes. Whoa. I think it would look better with a little bit more spacing. But and then we can do a mix between these two different geometries. So we can go like slowly blend from this kind of sphere cutoff to a null space. Something nifty. But yeah. One last thing I wanted to share quickly was just a brief video from the Miami event. So yeah, that was a super fun setup. Basically, this is a quick little demo using ShaderPark. Also, I'm like undecided if it should be called SPOPs for ShaderPark operators or blops. Kind of got to take a vote. Because I feel like it's so good for making like blobby shapes. And like, I mean, what's an easier way to get into shaders than making blobs? Basically, yeah, here's a quick little video of one of the pieces. Oh, you know what? I had this last time. I tried to just like play QuickTime from my computer. I was like, all right, I'm gonna do a video. There's nothing sketchy about doing a live demo of video, and it bricked my computer last time. Yeah, I was like, no way. Oh my god. Yeah, well, no, I think it's bricks. Yeah. Oh my god. Our very first meetup, I was like, all right, we'll swap between laptops. We'll do like a bunch of TouchDesigner projects. And then on our second one, I was like, only videos. Nothing can go wrong. Plug it in, immediately bricks on QuickTime. Yeah. Um, yeah, it's a good frame. But yeah, I think I'll wrap it here. Any questions?
Come on.
Yeah. Okay, so the question is what's the connection between RayTK, ShaderPark, T3D? Okay, so T3D is made by Joseph Pates, and it's basically a way of working with 3D textures in TouchDesigner. So if any of you have played, there is an actual operator in TouchDesigner called Texture 3D, and it's great. And you're going to reach a point, maybe if you're doing like instancing or you're like rendering particles, where you're going to want to like start to manipulate data, but you actually need more depth to that. So TouchDesigner doesn't have a great way at the moment to be able to work with 3D textures. So T3D is literally a whole suite of tools designed around working with 3D textures a lot easier. And what Yosef has done is like made things like a blur that will also operate on a 3D texture, a feedback that'll also work on that. So as another part of it is that it also works really well with rendering things like distance fields. Like if you've seen, so he also has like different starting shapes and things like that, and those under the hood are all shaders. Um, yeah, so basically, RayTK I think is a very similar not to T3D, but a similar approach maybe to ShaderPark as operators. It's basically a way of working with Raymarch shaders and I think 2D and 3D Raymarch shaders within TouchDesigner. And they've got a whole suite of tools and it's great. You should all definitely check it out. Um, yeah, I think those, and I think also RayTK as well has an output for working with T3D as well. So a lot of overlap, a lot of similarities between those. Um, yeah, think it's a really great toolkit as well. And I think all of these different tools I think have different design decisions, and so there's sort of slightly different ways of working with them. Um, one thing I will say is that if you make something in ShaderPark in within the TouchDesigner project, if you use the SPOPs network, you can actually take the final code from that and then just paste it in the browser.
and it will run and you can share it in the browser, which is really nice and something you normally can't really do in TouchDesigner projects. Yeah, like basically as you start to like chain together the different operators, it's literally just building the ShaderPark code for you. So you can just take the kind of final output from that and paste it in and it should create it. Yeah. That's gonna be just freely open source and available. Um, Ping me if you want to test it out. It is very kind of work in progress right now, and still, but I would love to have some beta testers. That'd be awesome. Yeah, and we'll post that on the ShaderPark GitHub and make a video on it too once it's like fully ready. That's where I feel like the naming of it could be slightly different. Yeah, so it's not related to pops. Um, but I think I'm interested to see how I could use some of the distance fields from it to maybe integrate with pops. That could be super fun. Yeah. I know, maybe bops. That's true. Yeah. And it is, yeah, we do need to see also how we can set up set it up to basically be able to work with like T3D and then also labs. Yeah, and also shout out again to Lyle for basically taking the like ability to create a whole operator family and extending that functionality into something we kind of reuse. I know Yosef had set it up initially and like hacked it together and has a good setup, but then it was great to be able to use that approach as well. I feel like now, so we did LOPS last time and we did SPOPs this time. So I feel like our next meetup, we just have to do a whole other operator family. So I'm looking for you all next. Yeah. Any other questions? All right. Thank you. Thanks, guys.